Welcome to yet another session of Everyday Mathematics. Here at Everyday Mathematics, as we say, we do enjoy solving the harder problems, but also we see and appreciate the beauty in the simpler problems. So today, we are still on the MIT 2022 Integration B qualifying exam. We are shifting from a treatment of trigonometrical functions to a look at the polynomials. And for the qualifying exam, we decided to divide this into a two-part series. So we are beginning with part one of a treatment of polynomials in the qualifying exam. And we have 4 problems. The first problem that we look at is problem number 3, which is the integration of x squared minus a product of the floor function of x and the row function of x, or the ceiling function of x, from x equals to 0 to x equals to 2022. Next problem is problem number 5, which is integration of x over the square root of x minus 1 plus the square root of x plus 1. This is an indefinite integral, so no limits. Problem number 8 is our next problem, which is the integration of x over 1 minus x to the power 4. This is also an indefinite integral. And the last problem that we'll look at today is the integration of the square root of 1 minus square root of x from x equals to 0 to x equals to 1. So before I jump onto our solutions today, I would like to just thank our subscribers. We are growing, and we do appreciate our subscribers for the support and the confidence they have shown us. We don't take that support for granted. We thank you so much, and we really, really appreciate it. For those of you who are here for the first time, we'd like to encourage you to subscribe. We like to ensure you that you won't regret that decision. For those of you who are here for the second, third, or fourth time, as always, we just really encourage you to subscribe to our channel. We will really, really need your support in this. Thank you so much. And now we're jumping on to the solutions. So problem number 3, integration of x squared minus the product of the floor function of x and the ceiling function of x from x equals to 0 to x equals to 2022. Now, what is a floor function? What is a ceiling function? A floor function tells us that when x is greater or equal to k, but less than k plus 1. In other words, when x is in between two successive integers, k and k plus 1, what the floor function of x within that interval is the lower value, which is k. And also for the ceiling function, when x is greater or less than or equal to k plus 1, and x is within that interval, then the ceiling function of x means that it is equals to k plus 1. So that's what that means. It's nothing very complicated. And what does that mean for integration? So the integration of x squared minus the floor function of x and ceiling function of x means that we'll have to divide that integration into the integration of x squared across that entire interval, 0 to 2022. And then we'll have to divide the 2022, 0 to 2022 interval into sub-intervals where we have successive integers taken into consideration. So within those strips, we can then integrate. Now we know that within those strips, the value for the floor function and the ceiling function are constant. So we'll just plug in the constant, which is the product of k and k plus 1, to signify the floor function of x and the ceiling function of x respectively. And then we'll move from k is equals to 0, in other words, 0th strip all the way to 2021, because we see there that the floor function will end at a value lower than 2022 by a unit interval. So what that means is that the first integral here is simply x to the power 3 over 3 and with the limits taken into consideration. And then since we're integrating stepwise, as we've shown here, since these are constants, so we have x with the interval k and k plus 1. So eventually, now we are reduced to the integral of x squared minus the summation of k squared plus k from k is equals to 0 to 2021. So we know from any book on pure mathematics or algebra that when you sum up k squared from k is equals to 1 to k is equals to 0 to k is equals to n, the summation value, the sum is n times n plus 1 times 2n plus 1 over 6. And then when you sum just k from k is equals to 0 to n, the sum is n times n plus 1 over 2. And you can prove this easily, but this is not the focus of our problem, so we'll just use these formulas. So therefore, our integration of x squared times the product of floor function of x and the ceiling function of x is x to the power 3 over 3 from 0 to 2022, the summation of k squared and k from k is equal to 0 to 2021. And so since our n is 2021 for the second, so n here would be 2021, n plus 1 would be 2022, 2n plus 1 would be 4043. And then for k, definitely n is 2021, n plus 1 is 2022 over 2, obviously here, and for this over 6. So going forward, we'll definitely substitute the power 3 there over 3. And then here, 2021 times 2022 times 4043 over 6 plus 2021 times 2022 over 2 into bracket. This all is subtracted from this cubed value here. And as you can see, we can now make everything in the denominator the same. So since 6 is the bigger value here, so if in order to make 6 the denominator here, we have to multiply 2 to the numerator. And in order to make 6 the denominator here, we have to multiply 3 by the numerator on this end. Now you can see that these two values are common here, so we can factor that out. And therefore, in the bracket, we can now have 2021 times 2022 into bracket 4043 plus this 3 here. And that now becomes in the bracket here, 2021 times 2022 times 4046 over 6, right? Then the next thing we can do is this divided by 2 is 2023, so pull 2 out here. We have 2 times 2021 times 2022 times 2023. And then what we can do next is we can factor out 2 times 2022. So when we factor that out, we have now remaining in the bigger bracket 2022 squared minus 2021 times 2023. So 2021 is the same as 2022 minus 1. 2023 is the same as 2022 plus 1. And so we have a product of the difference and the sum here. So what that means is that this is the same as 2022 squared minus 1 squared. And so you can see that in the bigger bracket here, we can now cancel 2022, and we are left with 1 in the bracket. So essentially, what that means is that our answer is 2022, and since 2 cancels with 6 here to leave 3 in the denominator, so we have 2022 divided by 3. 3 divided by 20 is 6, remainder 2. 22 divided by 3 is 7, remainder 1. 12 divided by 3 is 4. So our answer is 674. So that is our answer, and that's how you would quickly approach it. So on to problem number 5, the integration of x over x square root of x minus 1 plus square root of x plus 1. So the first thing I would want to do is try to simplify the denominator by multiplying both the numerator and denominator by the difference of root of x plus 1 and the root of x minus 1, such that this is the product of the sum and the difference. So we have the square of x plus 1 minus the square of the square root of x plus 1 minus the square of square root of x minus 1. So we have x plus 1 minus x minus 1 in the denominator. So the x cancel out, and so 1 minus 1 minus minus 1 is 1 plus 1, which is 2. So we have a half as our constant, x times x plus 1 minus x times x minus 1. So we can now separate this into two separate integrals, and we can simplify that as follows. So we would consider this as a product of two functions, and one of them would be considered, if we use integration by parts, one of them would be considered to be u, and the other one would be considered to be dv. So we have u1 here, dv1, u2 here, dv2 there. So since when we're integrating by parts, if you have a product u dv, that is same as uv minus the integration of v du. So if u1 is x, then du1 is 1. If dv1 is square root of x plus 1, then v1 is 2 over 3 x plus 1 to the power 3 over 2. Again, if u2 is x plus 1, then du2 is 1. And if dv, this is dv2, if dv2 is the square root of x minus 1, then v2 is 2 over 3 times x minus 1, the power 3 over 2. Now, that means that the integration, there's two integration, we've missed a half here, of the product of x and the square root of x plus 1 minus the integration of x and the square root of x minus 1 with the constants half to both is the same as half of u1 is x, v1 is 2 over 3 times x plus 1, the power 3 over 2, minus, since v1 is 2 over 3 times x plus 1, the power 3 over 2, the constant is out here. In the integration sign, we have x plus 1 to the power 3 over 2, minus u2 is x, and v2 is 2 over 3, x minus 1 to the power 3 over 2, minus v2 is simply 2 over 3, x minus 1 to the power 3 over 2. We bring the constant out. And the integration sign, we have x minus 1 to the power 3 over 2. So simplifying that, the integration of v1 is the same as 2 over 3 times 2 over 5 times x plus 1 to the power 5 over 2. Integration of v2 is 2 over 3 times 2 over 5 times x minus 1 to the power 5 over 2. Now we have an integration constant there. So we have now half a third, since this 2, this and that cancel, and this and that cancel, and then this and that cancel, and then this and that cancel. So we have these two here, shifting here, and then we have these two here, shifting with. And since this sign here interacts with this sign, we get a positive here, right? And then obviously this is negative. So we do have a third times x plus 1 to the power 3 over 2 minus 2 over 15 times x plus 1, 5 over 2 minus a third, x times x minus 1 to the power 3 over 2 plus 2 over 15 times x plus 1 to 5 over 2 plus c. Now, we could play some more tricks here to try and eliminate this 6x there, and that is we have a redundant negative 1 over 3 x plus 1 3 over 2 plus 1 over 3 x plus 1 3 over 2. So this would cancel out, but we're playing around so that we can add these two together so that eventually we can eliminate this x. The same thing happens here. So we can create a minus a third x minus 1 here, then plus 1 over 3 x minus 1 3 over 2. So this would cancel out, but we're going to now have to play around such that this interacts with this one and this one interacts with this one, right? So we're adding those together, and we're adding those together. So when you add this, you have now 1 plus x times x plus 1, 3 over 2. So this now becomes 5 over 2, a third 5 over 2, and a third plus 2 over 5 minus 2 over 5 means that now this reduces to 3 over 15 plus. The same thing happens here. When this interacts with this, you have x minus 1 to the power 1 times x minus 1 to the power 3 over 2. So this interacts, and we have now together 5 over 2 there. And so minus a third x minus 1, the power 5 over 2, plus 2 over 15, x plus 1, 5 over 2, becomes minus 3 over 15. Right? So this here, this constant with this constant, they interact together. Okay, and this constant here with its sign interacts with this one with the sign. So eventually we have negative a third x plus 1 3 over 2. Now here we have 3 over 15 x plus 1 5 over 2 minus a third x minus 1 3 over 2 minus 3 over 15 x minus 1 5 over 2 plus c. So these two have been created, and now we don't have a term that has x applied to them. That's just another simplification, but we could have used the previous expression as the answer. Anyway, going forward, we can reduce 3 over 15 into 1 over 5, 3 over 15 into 1 over 5, and that would be the simplified answer. Anyway, problem number 8, x over 1 minus x to the power of 4. The thing I would do there is use the product of the sum and the difference. So we have 1 minus x squared times 1 plus x squared being equal to 1 minus x to the power of 4. And then you could use partial fractions there. So 1 over 1 minus x squared plus 1 over 1 plus x squared times x. And so we have a half, because when you add this, you'd get 2 up. So to remove that 2 on the top, we multiply by half. So we have the integration of x over 1 minus x squared plus x over 1 plus x squared. So as you can see here, these are very simple integrals. It's the same as natural logarithm. When you integrate this of 1 minus x squared negative half as a constant, and here would have half of natural logarithm of 1 plus x squared. Okay, so you see half times that a half, we have now minus a quarter, natural logarithm of 1 minus x squared plus 1 over 4 natural logarithm of 1 plus x squared plus a constant. So using the rules of logarithm, this is same as this divided by this times the same constant. So we have a quarter natural logarithm of 1 plus x squared over 1 minus x squared plus integration constant. Problem number 12. The integration from 0 to 1 of the square root of 1 minus square root of x. The first thing I would do for this problem is to let u be equal to square root of x such that du dx is 1 over 2 square root of x, which is the same as, since the square root of x is the same as u, so we have 2u du is equals to dx. And so the limits here, when x is equals to 0, u would be 0, x is equals to 1, u would be 1. So this means that this integral is the same as the integral from u is equals to 0 to u is equals to 1 of the square root of the integration of square root of 1 minus u times du 2u du in place of dx. So this means that we have now an integration of 2 times u times square root of 1 minus u. And so we can use integration by parts where u is our u and dv is square root of 1 minus u, so that v is negative 2 over 3, 1 minus u to the power 3 over 2. And obviously, this is uv, taking the limits into consideration, 0 and 1, plus 2 over 3, since we have minus, so it becomes a plus, the integration from 0 to 1 of 1 minus u to the power 3 over 2. So if you substitute the limits in here, when u is 0, this entire thing becomes 0. When u is equals to 1, this entire thing becomes 0. So that means that this entire initial part is 0. And then when you integrate this, because there's a negative u here, this constant becomes a u. And then you have 2 over 3 times 2 over 5, 1 minus u to the power 5 over 2. So when you substitute the limits here, when u is equals to 1, this becomes 0. Then you have minus, which becomes a positive. When u is 0, this becomes 1. And so 2 over 3 times 2 over 5, which is 4 over 15, times 2, which is a constant out here. So the answer is 8 over 15. And that is the answer for that last problem. So yeah, thank you so much for hanging out with us. It's been an absolute fun moment to be here sharing the solutions with you guys. Thank you so much for hanging out with us. We really encourage you to subscribe. Until next time, tutaluha la prochaine fois.